Okay, so this is H2 Maths in the applications of integration question. So R is the finite region in the first quadrant, which is bounded by this curve, which is an ellipse. Okay, so this is an ellipse. You can just sketch the graph on the axis, and the line x over a plus y over b equals to 1. So this one is a straight line where you can rearrange to be y equals to y over b equals to 1 minus of x over a. So y equals to b minus b over a x. So it's a straight line graph, negative gradient, okay? So write down the integral representing the area of R. So what happens is that I have drawn the curves here. So you can see the ellipse. This is the A, this is the B, okay, based on this. And the green line, okay, which is a straight line graph. Okay, the gradient is B over A. So that's why you get B over A and negative. So, and it cuts at y equals to b, so that it cuts at y equals to b. So it will be at a here. Okay. So the area will definitely be here, the R. Okay, this is the R. This is where R is. Okay, all this you also need to be drawn in as part of your working. Okay. So that you'll be able, it's not just, it may not be part of the marking scheme, but it does help in terms of the examiner understanding your working, and also in terms of helping yourself being less careless. So we need to find the area, we can actually integrate towards the x-axis. Okay, now we can make this, we can take this equation and then make y the subject. So y square over b square equals to 1 minus x square over a square. And y equals to plus minus b of square root 1 minus x square over a square. Now, when do we use the plus and when do we use the minus? The top part here is where we will use the plus, and the bottom part is where there's the minus part. Okay, so the positive y plus, the negative y minus. Okay, so we have, when we take the top part, okay, we choose the part where uh it's the top part. Okay, so the top part of the graph, the top part of the ellipse, of the ellipse uh ellipse. Okay, y equals to b square root of 1 minus x square over a square. Okay, so this, by the way, if you want to plot into the GC along with this graph, okay, without using the conics app, this will be what you can do to put into the just the graph, okay, the y equals part. So you can use this straight into the GC. Okay, so now back to the question. Now to find R, what you will need to do is integrate the top part minus the bottom part. Okay, so therefore area R is equals to integrate, because we are going to go for dx, so we'll be doing 0 to a, top graph minus bottom graph. So the top graph is b square root of 1 minus x square over a square, okay, minus of b minus b over ax dx. So just write down, we can leave this as part of the answer. Okay, but generally for the bottom part, because it is a triangle, I would not like to integrate. I will just use the area of triangle to find fast. Okay, so this one is going to just be part of the answer for the definite integral, but when we want to do it, we don't need it. Okay, so this is the answer. Now next part, you need to evaluate the integral using the substitution x equals to a sine theta. So we will need to substitute a sine theta. So we can let this continue, equals 0 to a of b square root of 1 minus x square over a square dx minus half base times height, half ab. Okay, half ab. So we need to sub in x equals to a sine theta. Remember, for substitution, right, we need to change 4 things. This, okay? The x inside, the limits, and dx. So before we change it, okay, we need we need to find what is dx. So sub x equals to a sine theta, dx d theta equals to a cosine theta. Okay, why we need this? Because this is to substitute this part. So when I put like, let's just change it to red. When I, orange, okay, when I put it as d theta here, I multiply by d theta. So you can see it's like cancelling out, right? Okay, so this is the way we need to change the limits to d theta. Okay, but because of that, there's a dx d theta, which we will need it. Now, the other two that we need to change is the 0 and a. When x equals to 0, a equals to 0. When x equals to a, sine theta is 1. Okay, this theta. Okay. Theta equals to 0. Then theta equals to pi over 2. Okay, because sine pi over 2 is 1. So now we can do integration. Therefore, your area R is equals to integrate from 0 to pi over 2 b square root of 1 minus sine square theta, because a square sine square theta divided by a square, okay? Then after that, a cosine theta d theta minus half ab. Now, so this becomes an easier integration already, okay? So, when you do 1 minus sine square theta, you know that it's going to be cosine square theta. So this is when you square, it's going to be cosine. Okay, so I will just change this to AB cosine square theta minus half AB. Now, cosine square theta, okay, this is standard integration already. You are going to change it to half plus half cosine of 2 theta. Okay, you can see the AB is here. Theta over 2 plus sine 2 theta over 4. Okay, because when you differentiate this is 2 cosine 2 theta. So 0 to pi over 2. AB, now when we sub in pi over 2 here, it's going to get pi over 4 plus 0. Okay, sine pi is going to be 0. Minus 0. Okay, here is 0 and sub in here is 0. Okay, so now we get AB of pi over 4 minus AB over 2. Okay, if you want to factorize further, you can take out AB over 2. You're left with pi over 2 minus 1. Okay, so they asked for evaluate the integral, so this is the integral solved. They did not ask, let's see. They did not ask for area. You know, if they ask for area, you could also include the units here. Okay, so units square. Then, yeah, that will be the answer. Okay, that's area R.